Hello everyone, I'm trying to walk you through this question. Q3, Q2 of part 4 of our ROF homework exercise. So you are given a Mueller waveguide. Mueller waveguide is the same as parallel plant waveguides. The light inside will undergo successive internal reflections. First, we need to prove that the wave number with the index m in the Mueller has the following form. Here, I have to emphasize that I think this formula is wrong. There shouldn't be m inside. Part B of the question shows that the group velocity of the mode m can be written as follows. So it's not difficult. The group velocity is d omega d beta. So now we are ready. Now you are looking at my whiteboard. We are dealing with question 2. So to start with, we are given a parallel waveguide. So it may be a very wide waveguide. And the height here is d. And we know that the three-dimensional wave number inside in between the metal plates is k. K is given by k squared equals to kx squared plus ky squared plus kx squared. Remember, in a parallel waveguide, you ignore the parallel one because we have shown the parallel, the wave, the field component is invariance along the x-axis. So we can cancel this term and we get k. So we cancel the other term. This term, no kx. So in this case, we get k z squared is equal to minus ky squared. So in this case, ky is equal to m pi over d. Yeah, assuming that the m is the number of poles. This is how we, yeah. If you are familiar with rectangular waveguide, then this is exactly what we have done in rectangular waveguide. So in this case, I can say kz squared. So we substitute this here into 1. Then get this. And k, we are now dealing with air, so assuming that there is no other dielectric material inside between the parallel plates, so we can assume k naught as well. So now we can we need to work out the cutoff frequency. The cutoff frequency is equal to m pi c over d. This is the cutoff. Um, and hence we have k v square equal to k naught minus uh, omega c over c. But uh, we know that k v square is k naught square, and then 1 minus omega c over c, k naught. So k naught is equal to omega c, and then k naught here can be written as omega c as well. So from here you can quickly conclude that k naught is equal to 1 minus omega c over omega. So that's it. So the suggested answer for the question has the m here, which I don't agree. I don't agree with. So I think this is the part A of the question. Part B. Part B, we are going to find out the group velocity. The group velocity is equal to d omega sorry d omega d beta. So we start from this formula. So now I'm going to clean up the whiteboard. And I will make good use of this formula. So now we square both sides of the question. Now, but by the way, k of z is equal to beta m. Beta. And so now if you square both sides of the equation, we get beta k naught 1 minus omega c over omega square. If we differentiate both sides of the equation, we get 2 beta d beta. We differentiate both sides of the equation with respect to omega. No, but before that, I think it's better to simplify this equation first. Beta square, so k naught is equal to omega square divided by c square, and then 1 minus omega c square omega square. So if you work this out, you will get this. And then here it's omega c square c square. So if you differentiate both sides of the equation with respect to omega, you will get the left side become like this, the right side become 2 omega and then c squared, and this one becomes 0. And as a result, if you do a little bit of the arrangement here, and we get beta c squared 2 and 2 that cancel out. So the group velocity, as was this initially defined, is like this. So this is part B of the question. Part B. Okay, if you have further questions, please leave your question to the comment section. Thank you. Bye-bye.